Probability. Before understanding the term probability, we must understand some terms related to probability. First, random experiment. An experiment in which all possible results are known in advance, but none of them can be predicted with certainty and there is equal possibility for each result, is known as a random experiment. For example, throwing a dice. Outcome. Result of random experiment is called as an outcome. Sample space. Set of all possible outcomes of a random experiment is called a sample space. Sample space is denoted by the alphabet S. Total possibilities are written in curly brackets, that is, S is equal to 1, 2, 3, 4, 5, 6. Number of elements in sample space is denoted by N of S, which is equal to 6. Let us consider a game of tug of war played between two teams, Team A and Team B. This game can end in either of the three results. 1. Team A wins the match. 2. Team B wins the match. 3. Or the game ends in a tie between Team A and B. Therefore, there are three outcomes. S is equal to Team A wins, Team B wins, or a tie. Number of S is equal to 3. There is going to be only one result amongst these three, but we cannot exactly predict which team will win, or probably there would be a tie. So any kind of sports like cricket or football in itself is a random experiment. A random experiment using playing cards. Let us consider a deck of well-shuffled playing cards. In all, there are 52 playing cards, therefore N of S is equal to 52. There are 26 black cards, therefore N of S is equal to 26. There are 26 red cards, therefore N of S is equal to 26. There are 13 spade, club, heart and diamond cards for each suit, therefore N of S is equal to 13 for each of them. Ace cards. There are 4 ace cards in all, that is, each suit contains one ace card. Number of ace cards is equal to 4. Face cards. King, Queen and Jack are considered as face cards. King. There are 4 king cards in all. That is, each suit contains one king. Queen. There are 4 queen cards in all. That is, each suit contains one queen. Jack. There are 4 jack cards in all. That is, each suit contains one jack. Therefore, total face cards is equal to 4 plus 4 plus 4 is equal to 12. Tossing a coin is also an example of a random experiment. Sample space of some random experiments. When one coin is tossed, there are 2 possibilities, head or tail. Therefore, S is equal to head or tail. N of S is equal to 2. When 2 coins are tossed, there are 4 possibilities. Therefore, S is equal to head head, head tail, tail head or tail tail. N of S is equal to 4. When 3 coins are tossed, there are 8 possibilities. Therefore, S is equal to head head head, head head tail, head tail head, tail head head, tail head tail, tail tail head, head tail tail and tail tail tail. N of S is equal to 8. Dice. First, when a dice is thrown, there are 6 possibilities. 1, 2, 3, 4, 5, 6. Therefore, S is equal to 1, 2, 3, 4, 5, 6. Therefore, N of S is equal to 6. When 2 dice are thrown, there are 36 possibilities. 1, 1, 1, 2, 1, 3, up to 6, 4, 6, 5, 6, 6. S is equal to 1, 1, 1, 2, 1, 3, up to 64, 65, 66. Therefore, n of s is equal to 36. Event. A set of favorable outcomes of a given sample space is an event. An event is defined by any capital letter A, B, C, etc. except S. For example, let A be an event of getting odd number when a dice is thrown. Therefore, sample space S contains 6 elements. From 1 to 6, there are 3 odd numbers, that is 1, 3, 5. Then the favorable outcomes are A is equal to 1, 3, 5. The number of elements in event A is denoted by n of A. Here, n of A is equal to 3. We can clearly see that A is a subset of S. Types of events. When a dice is thrown, there are 6 possibilities. Therefore, S is equal to 1, 2, 3, 4, 5, 6. Therefore, n of S is equal to 6. Certain event. An event which contains all the sample points of sample space is called as a certain event. Let us consider an example. Let B be an event of getting a number less than 10. We know that when a dice is thrown, there are 6 possibilities of getting a number less than 10. Therefore, event B is a certain event. It contains all the elements of sample space. Impossible events. An event which does not contain any element of sample space is called an impossible event. Example, when a dice is thrown, every time we throw a dice, we are going to get the numbers from 1 to 6. We will never get any number greater than 6, meaning we will never get a number greater than 8. Therefore, set A is empty. Therefore, it is an impossible event. Mutually exclusive events. If 2 events do not contain any common element, they are said to be mutually exclusive event. Example, when a dice is thrown, let B be an event of getting a number less than 3 and C be an event of getting a number more than 3. B is an event of getting a number less than 3, that is 1 and 2. C is an event of getting a number more than 3, that is 4, 5 and 6. Set B and C does not contain any common element. In short, 2 events B and C are said to be mutually exclusive if B intersection C is a null set. Complementary event. A and B, 2 events are said to be complementary if 1. A intersection B is equal to empty set. 2. A union B is equal to sample space S. Example, a dice is thrown. A is an event of getting even numbers. B is an event of getting odd number. Here A is equal to 2, 4, 6. B is equal to 1, 3, 5. We can see that there is no common element in set A and set B. Therefore, A intersection B is equal to empty set. And A union B is equal to 1, 2, 3, 4, 5, 6. A union B contains all elements of sample space S. Such events are said to be complementary events. Probability of an event. Probability of an event is ratio of number of possible outcomes to the total number of outcomes. If A is an event, then probability of an event A is number of elements in A upon number of element in sample space S. Example, a coin is tossed. Find the probability of getting head. When a coin is tossed, there are 2 possibilities of getting a head or a tail. Therefore, number of elements in sample space is 2. A is an event of getting a head. There is only 1 element in event A. Therefore, P of A is equal to N of A upon N of S, which is equal to 1 upon 2. Examples, 2 coins are tossed. Find the probability of 1. Getting 2 heads, 2. At least 1 tail, 3. At most one tail. Solution. 2 coins are tossed. There are 4 possibilities. Therefore, sample space S is equal to head head, head tail, tail head, tail tail. That is, n of S is equal to 4. Let A be an event of getting 2 heads. That is, A is equal to head head. Therefore, P of A is equal to n of A upon n of S, which is equal to 1 upon 4. Let B be an event of getting at least one tail. At least one tail means one or more than one tail. That is, B is equal to tail tail, head tail, tail head. Therefore, n of B is equal to 3. Therefore, P of A is equal to n of B upon n of S, which is equal to 3 upon 4. Let C be an event of getting at most one tail. At most one means less than or equal to 1. So even if there is no tail, it is accepted. That is, C is equal to head head, tail head, head tail. Therefore, n of C is equal to 3. Therefore, P of C is equal to n of C upon n of S, which is equal to 3 upon 4. Example, a dice is thrown. Find the probability of getting even prime number. Sample space S is equal to 1, 2, 3, 4, 5, 6. Therefore, n of S is equal to 6. Let A be an event of getting an even prime number. A is equal to 2, since 2 is the only even prime number. Therefore, n of A is equal to 1. Hence, the probability of getting an even prime number is n of A upon n of S, which is equal to 1 upon 6. Solve these for practice.
Example, a missing helicopter is reported to have crashed somewhere in the rectangular region shown in figure. What is the probability that it crashed inside the lake shown in the figure? Solution. The helicopter is equally likely to crash anywhere in the region. Area of the entire region where the helicopter can crash equals to 4.5 into 9 km square equals to 40.5 km square. Area of the lake equals to 2.5 into 3 km square equals to 7.5 km square. Therefore, the probability of helicopter crashed in the lake equals to 7.5 by 40.5 equals to 75 by 405 equals to 5 by 27. Therefore, the probability of helicopter crashed in the lake is 5 upon 27. A carton consists of 100 shirts, of which 88 are good, 8 have minor defects and 4 have major defects. Jimmy, a trader, will only accept the shirts which are good, but Sujata, another trader, will only reject the shirts which have major defects. One shirt is drawn at random from the carton. What is the probability that 1. It is acceptable to Jimmy, 2. It is acceptable to Sujata? Solution. One shirt is drawn at random from the carton of 100 shirts. Therefore, there are 100 equally likely outcomes. 1. The number of outcomes favorable, that is acceptable to Jimmy, equals to 88. Therefore, the probability of shirt acceptable to Jimmy equal to 88 upon 100, that is equal to 0.88. 2. The number of outcomes favorable to Sujata is equal to 88 plus 8 equal to 96. So the probability of shirt is acceptable to Sujata is equal to 96 upon 100 equal to 0.96. Jimmy's acceptable probability is 0.88. Sujata's acceptable probability is 0.96. Try these for practice.